Alrighty, so for this next video here, I'm going to be looking at the items in green, which the items in green here, 4, 5, 7 through 9, 13, and I'm trying to think if one of the proofs also includes isosceles. So we're going to be dealing with some isosceles triangles here, a little bit of equilateral as well, and what that entails, okay? So before we get to a couple of these example problems, I'm going to just kind of briefly describe some things that are going on with isosceles triangles, okay? So an isosceles triangle, remember, has two sides that are congruent, okay? So I've got two sides that are congruent, all right? I've also got across from those sides two base angles that are congruent, okay? So it's almost like you may have learned about symmetry last year in math. It's almost like I've got symmetry in this triangle. One side is going to match the other, okay? Now, it's not always standing up like this, okay? You'll notice in the notes that we did on this that I had an isosceles triangle where maybe top and bottom kind of were congruent. My base angles are still opposite, so on the other side of those congruent sides, okay? The angle at the top, okay, the one that's kind of different, is called the vertex angle. Some people just call it a vertex, but it's really the vertex angle, okay? So that one is different, okay? Equilateral triangles they have all three sides congruent. Okay, so it'd be something like this. Boom, boom, boom. All three the same thing. Maybe it's 5, 5, and 5, 6, 6, 6, 7, 7, 7, 8, 8, 8, whatever. 90, 90, 90. We don't know. Okay, so side lengths are all going to be the same. Also, you've got three angles that are congruent, and more specifically, they're 60 degrees. Okay, and I can show that. Y'all had a review question where I added up those angles inside. And remember, the three angles in a triangle have to sum to be 180. Well, since all three angles are the same, that means each one is going to have to be 60 degrees. Okay? So that's the difference between those two triangles, okay? Now you're going to be asked a couple different things on your test, okay? One of the things, if I were to label this triangle here, okay, A, B, and C, so I've got the vertex angle is angle C, the base angles are angle A and angle B, okay? Another way to write this out, if I were to use the three letters, you could have ACB, so it's still that angle at C there for the vertex, or for the base angles, I could have angle CAB and angle CBA. Talking about the angle centered at A and the one centered at B there. Okay. So remember, there's a couple different ways that you can write out angles when you're naming them. Okay. So on your quiz, or on your test, excuse me, so I'm going to say something like, if angle BAC is congruent to angle, let's say ABC, then, and I'm going to put blank is congruent to blank, okay? So whenever I've got two angles that are congruent in the same triangle, then you can tell me that two sides are going to be congruent. So if I look at angle A, the side across from it is CB. If I look at angle B, then the side opposite of it is AC. So if these two angles are congruent, I can conclude that their opposite sides are congruent as well. Okay. This also works backwards. So if I were to say that AC is congruent to BC, then now I can work backwards. The angle opposite of AC is angle CBA. The angle opposite of BC is this one at A, so like CAB. Okay, so it works backwards and forwards there. So that's kind of like what you have to do for number 9 there. I give you some angles, like 1 and 2. You have to tell me what are the opposite sides. Okay, so they kind of overlap. So you're only going to be looking at one triangle at a time. So if I'm looking at like 1 and 2, I'm only looking at the triangle EDF. Okay. If I'm looking at angle 3 and 4, I'm looking at that small triangle BDC. Okay. And if I'm looking at, the other triangle, I've got ABC as well. So you kind of got 3 options. So you got to look at what I give you and figure out which of those 3 triangles, like 1 and 2, is in. So it's clearly an EDF. Or if I look at angle ABC and angle ACB, I'm talking about that triangle ABC. If I'm looking at just BD and CD, well, I'm looking at triangle BDC. Okay. Alright, so the other thing that you're dealing with when you've got isosceles triangles, you got to know the difference between base angles and vertex angles. So hopefully what I just described there should help you out. Okay. So if I've got base angles of 90 degrees, okay, that means each one would have to be 90 degrees. So when you think about this question, I want you to think about what the sum of all 3 angles is allowed to be in a triangle. Okay. Vertex angle, if it's 90, then how would you maybe find the 2 base angles, which you know have to be the same? So the last 2 remaining angles in that triangle. Again, think about triangles. The interior angles sum to be 180. Okay. Alright, so for 5, I'm going to do an example kind of like that. So it says an isosceles triangle has an angle measuring 55 degrees. What's the 2 possible sets of angles for this triangle? Okay, so I'm actually going to do a different measure here. Since it is, let's say, 943, I'm going to pick 52 degrees as an angle. Okay. So let's say I've got an angle given to me that is 52 degrees. Okay. So if it's an isosceles triangle, I've got 2 options of where I could put this angle. Okay. So one option is that it's a base angle, in which case I know another angle is 52 degrees. Or another option is that the 52 is the vertex angle, and I've got to find the base angles. Okay. So if I look at this first one, I know that the 3 angles have to sum to equal 180. So I've got x plus 104 is 180. So x equals 76 degrees. Okay. So one option is to have angles of 52, excuse me, not 55. So 52, 52, and 76. Or, if I look at the other one, let's say I've got x plus 52 is 180. So I've got 2x plus 52 is 180. When I subtract, I get 2x is 128. Or x is going to be 64 degrees. So another option is I've got 64, 64, and 52. Okay, so I've got two different options there for an isosceles triangle. So this is when you've got the 52 as the base angle or the vertex angle. Okay, so two different options there. So that's like number 5. For number 7, so basically for 7, you're just trying to figure out which two sides are equal. So when I go to look, OT, since T is the vertex, so I've got HOT here, T is the vertex at the top. So when I go to look, OT is going to be the same thing as HT, okay? And since those are the congruent sides, then that means they're going to have to be set equal to each other. Okay. For 8, again, I've got to think about base angles here. Okay, so I'm dealing with angles. Okay, so it says the vertex is G. Okay, so that means G is only written in that triangle once. That means E and O are the base angles. So when I go to fill out my triangle, since E and O are the base angles, I would basically copy it twice. Okay, so I'm going to do an example like this one. This is like number 8. So let's say that I give you triangle VPI is isosceles with a vertex of I. So I always am just in the habit of writing my vertex angle up top just because, you know, old habits die hard, right? So V and P, as long as you've got your vertex angle in between your two congruent sides, you're fine. Okay. They also tell me that the measurement of angle V is 5x plus 1. The measurement of angle I is 6x minus, I don't know, 4. It's probably not going to come out as a whole number, but we'll see how far it goes. Alright, so that means we can conclude that the measurement of angle P is going to be the same as whatever V is. So I can copy that 5x plus 1. So now I know that the interior angle sum is 180. So I've got 5x plus 1 plus 5x plus 1. I'm adding all three angles. Plus 6x minus 4 is 180. So when I combine like terms, I get 16x minus 2 equals 180. So 16x is 182. So x is going to be 1. Hold on. So 11 point. Let's see. 375, I believe. I don't have a calculator with me, so I believe it's 11.375. Okay. And if I'm wrong on that one, I'm sorry. You can give me a hard time the day you take your test, right? But I believe it's 11.375. If I asked for one of the angles, you would just have to plug in that 11.375 to find out like what V is or I or P. Okay. Looking back at the test review here, let's see. When I say classified triangle, basically you're double checking, is it isosceles, or if those angles all come out to be 60 degrees, we said earlier that it is equilateral. Okay. The last one here in green, 13. Um, Again, isosceles triangle. That means I've got two sides that are congruent. Okay, so I'd have to set these two sides equal to each other. Don't let the fraction throw you off. If you want to change it to 1.5 and 3.5, that's fine by me. Okay. If you can do it as a fraction, go for it. It'll be good practice. So I believe that's all the isosceles ones. Again, you'll have to use isosceles for 18, just because now I know that two sides are congruent, okay? So just be mindful of that when you go to do that proof. I'm not going to do the proofs yet for this one. We'll do that in example in red, okay? So now I want you to go ahead and complete those ones in green. See what you can get, and then let me know if you have any questions.